Okay, so solving inequalities. Basically, this is like solving equations, but with a greater than, less than, greater than or equal to, less than or equal to inequality. We can't call it an equation. So write this down. Now, I've given you problems that look like this before, and it puzzles you. But if I told you to solve this, what would you do? Minus 4. You do the same thing with an inequality that you do with an equation. There's one exception, and I'll talk about that in just a minute. So we're going to subtract 4. So 3x is greater than 7. I have students, for some reason, that want to leave their answer like this. So if you had 3x is equal to 7, would you leave that answer like that? What would you do to continue to get x by itself? Divide by 3. We do the same exact thing here, except instead of an equals, we have an inequality. Now, on today's lesson, you're going to graph these on a number line. And the number line, I believe, is numbered for you. Okay, so you don't have to number them. So I want to show a graph on a number line where all x's are greater than 7 over 3. Well, what would that be approximately in a mixed number? Not 1, 2 1/3, which is just a little over 2. Remember, we talked about this when we graphed the inequalities before, and kind of how we have to estimate. So, do you remember from any lessons before anything about whether it's an open or closed circle?
If it's not equal to, it's an open circle.
If it's not equal to, it's an open circle. So you might want to write these down. Remember how we did an open line or a dashed line? Okay. If it does not have an equal to, it is an open circle. And if it has an equal to, it is a solid circle. Okay. So, I want you to forget about the alligator because we're going to be able to read these backwards and forwards. I'm always coming from the perspective of x because x is my unknown. So what this is doing is this is telling me any value of x that is greater than 2 1/3 will make this equation true. So I'm going to put a circle about where 2 1/3 would be. Now, where would I draw my arrow to show all the values greater than x?
Right.
To the right. Okay, you can make this solid, you can draw it up here. I don't really care how you indicate to the right. Now, let's check our answer. Pick a number greater than 2 1/3. 22? What's 3 times 22? 66 plus 4 is 70 greater than 11. Now, you might want to make sure you're a little closer. Let's try 3. 2 times 3. 3 times 3 plus 4. Is that greater than 11? Okay. So it's just like we're trying to indicate because there's no possible way that I can list all the answers. It's an infinite number of solutions, okay? That all the values greater than 2 1/3 will satisfy or make this equation true. Yes, sir?
But 2 fits that. Oh, wait, no.
Okay. Good check, though. Good check. Okay, let's look at another one. So write this next one down. Y'all got the open circle, solid circle. Okay. Now, you may not like solving with the x on the right, but you're going to have to get used to it. So if this was an equals, what would I do first?
Subtract 3.
Subtract the 3. So now I have 11 is greater than 2x. We can't leave it like that. What am I going to do? Divide by 2. So 5.5 is greater than x. Now, this is why I want you to forget the alligator. Because if you were ever taught to draw your arrow in the direction of the inequality, you're going to get it wrong here. That only worked when you were in middle school and all the x's were on the left. It's kind of like in first grade when you were learning to add and subtract and they told you you couldn't say 1 minus 2. You know you can now. It's just a matter of what you have learned. Okay, so from the perspective of the x, read it backwards. 5.5 is greater than x, or x is what? Less than 5.5. X, if you read it backwards, x and then the small part of the inequality, so x is less than 5.5. Will this be an open circle or a closed circle?
Open.
Open. And where are all the values less than? To the left. So you have to look at it from the perspective of the inequality, of the x with the inequality. Now, there's one major difference about inequalities and equations. Write this down. This is extremely important. If you multiply or divide by a negative, you must flip the inequality. If you multiply or divide by a negative, you must flip the inequality. That's going to be where a big mistake happens. All right, let me give you an example. Okay, how would I start getting x by itself?
Subtract 2.
Subtract 2. So that gives me, what am I going to bring down? Negative 3x is less than or equal to 2. If I multiply or divide by a negative, so what have I got to divide by? Negative 3. So I divided by a negative, so I have to flip the inequality. It's no longer less than, it is now greater than. Okay, but let me show you what it is not. Everybody look up here. Okay, what would I do to solve this one? Minus 6. So 2x is less than or equal to negative 5. Now, I want you to think about what I told you. If you multiply or divide by a negative, you flip the inequality. I've got a negative, but what I divided by is positive 2. So be extremely careful that you don't think any negative over there flips the inequality. It has to be what I divide by. Okay? You understand what I'm saying? This -5, I did not divide by -5, I divided by 2. Okay? Now, let me give you one more type of example, and then I'm going to let you do your classwork. Now you have a fraction. Guys, we talked about this when we did this with equations. You have a couple of options. The first thing that I would do is I would combine my constants. Who can tell me what my constants are up here? Which ones are my constants? The 3 is one of them, and the 12 is the other. How would I combine those? Subtract the 3, which gives me x over 4 greater than or equal to 9. Now I have a denominator I want to get rid of. How do you always and forever get rid of a denominator? Multiply it. So x, did I multiply by a negative? No. X is greater than or equal to 36. Now, how many of y'all, when I first put this up there, wanted to multiply by 4? Anybody admit to wanting to multiply by 4? Okay, you absolutely can. But don't mistake multiplying it one time on the left and one time on the right. That's not a rule. When you multiply everything. So if you wanted to multiply by 4 here, you would multiply by 4 to every single term. And then you would subtract and move this over. Okay? I think sometimes my students have seen this happen and make the assumption that you do it one time on the right and one time to the left. But that is a wrong assumption. So make sure that if you multiply ahead of time, it doesn't matter if there's 10 terms there, you multiply every single term. Okay, are there questions about inequalities? It works just like equations, except for if you multiply or divide by a negative, you have to flip the inequality. Okay. So let me give